So 89. So it says 9a d to the minus 2. 8a minus 2b, and this whole thing is to the minus 2. And then it's times 3a minus 2b over 2a squared b to the minus 2. And that's to the third power. Now what I'm going to do is inside of the brackets, I'm going to do that first. So the first bracketed item, and I'm going to write that 9 is 3 squared, and then the 8 in the denominator as a 2 cubed, right? Now, the a's, what would you do with the a's? There's an a first in the numerator, a minus 2 in the denominator. You take the minus 2 out, don't you?
Yeah, it's negative.
So it'd be a third in the numerator, correct?
Yeah.
And then the b's, that b minus 2 in the numerator has to go down as a b plus, right?
Yeah.
So this would be b third. Everyone with me? This one has got to go down as a plus 2 in the denominator. And this one has to go up as a plus 2 exponent. So then you get a third in the numerator, b third in the denominator as positive exponents. Right, Aaron? Okay. You're just looking at it, you're not...
Oh, I already did it, so no.
You did it different?
No, I already.
Okay, all right. You're good with it, you're just watching. Okay, so now this one, I'm going to simplify what's inside. So it's still a 3 and a 2, but now the a minus 2 up here will go down as a plus, right? So then we have an a4. Are you good with it? Okay. And then that b minus 2 goes up, so we have a b3. So we've done everything inside that bracket. All right. Now, these two numbers here, this one and this one, I'm going to take care of those. When they go inside, they multiply, right? They multiply the exponents. So I'm going, and then I'm just going to drop the brackets when I'm doing it. So I have a 3. I have that 3, and it's going to be this minus 2 up here times a positive 2, so I have a minus 4. And I'm not going to try to go clear up my negatives until later. Then I'm going to take this minus 2 times that 3, so I have an a minus 6. Is everyone good with it? Now I'm going to go in the denominator, and this 2 to the third is 2 minus 6, and then it's b minus 6. Everyone good with that? Now I'm going to take this 3 that's up here and run it down. So this is 3 to the third. I got to go 3 times 1. Then the b, it's b third times 3 is b9, right? Then it's 2 third, and a 3 times 4 is 12. Is that good? All right. Now, on numerators and denominators, we can actually think of this as this line just goes through, right? Like that. It's all multiplied together. Now, what I want to do is I just want to combine the bases. And I'm going to start with that 3. And what I have to do is I have to add the minus 4 and then add the 3, right? Now, the A's, do you want to take, if you take this A, minus 6, it actually has to go into the denominator as a plus, don't it? And be added down here. So it's going to have to be A18. Is that doing too much without intermediate steps? No, I don't know. Is that too much? I'm taking this A6, going down here, and making it a plus 6, and adding it to the A12. So it's A18 in the denominator. Is that good? Okay. Now then, the next thing is, just up here, I got this B minus 6. So I'm going to go up here, and I'm going to add it up here. S going to the numerator, become a B plus 6, and then the B9, B6 add. Are you good with that? Okay. So then that's going to be B15. So now just to go back, I've taken care of this. I've taken care of this. I've taken care of this. I haven't taken care of my 2's, right? So I got, I'm just going to leave it. I'm just going to leave that. It's 2, well, dang it. I don't want to write red. It's 2 minus 6 plus 3. Now, I left my constant bases as, I'm just going to clean them up later. But are you good with the B15, A18? So then this is actually 2 to the negative 1, 3 to the negative 1 in the numerator, 2 to the minus 3 in the denominator, and I still have the B15 A. Well, I'm just making a mess of this thing. It's B15 A18. Then to clean this all up, this 2 has to go in the numerator. Third, B15. The 3 has to come down. 3 to minus 1, I don't have to put any exponents. A18. And that should be the answer. Now someone asked the same one this morning, or earlier class, and it's 8 over 3, right? But I'm just telling you that it's better. I'll take the 2 third, I'll take 8, whichever expanded. But it's just better to go with factor 4. Did that answer
Yes,
where you
it
were
did.
exempt? Yeah. Okay, then we'll look at. We're going to look at scientific notation. And I'll look at 92. 92. This is 7 zeros and a 5. Now scientific notation says this. You take whatever number you have and you write it so that there's 1 digit to the left of the decimal. 1 digit to the left of the decimal. That's all you should do. So this would be 5, and if there's only zeros to the right, the convention is you put the decimal and put a 0. And then you multiply this by whatever you would have to do to this number to get it to that in a decimal. And it's always powers of 10, because 10 moves the decimal place one place, right? If you multiply by 10, it moves the decimal place right. If you divide by 10, it moves the decimal place left. So in essence, how many times would you have to divide 5 to get this number up here? And you do that by counting the decimal places. So I go 1, then I move 2, 3, 4, 5, 7, 8. And I have to divide by 10 8 times to get the decimal place back. Now, here's another way you can look at this. It works well going from scientific notation back when you got a decimal like this. You will have to have this number right up here will have to be 1 greater than the number of zeros that you have. 1, 2, 3, 4, 5, 6, 7. So it's going to have to be minus 8. It works when it's negative. Not necessarily you count the zeros when it's positive, because you can have something, with a 3-digit number or a 4-digit number. You always have 1 digit to the left of the decimal, so you can count the number of zeros, and you can add 1 to that as a negative. But be very careful doing it when it's positive. That system will work. I'll give you an example. If you have 3.6 and you have 10 to the 8th, then you would do 3, 6, and do 7 zeros and move your decimal. But if you had 3.61 times 10 to the 8th, then that would be 3.36. That would be 361, but rather than 7 zeros, you would have 6 to get to the right decimal place. Because, see, you have 2 digits to the left, not 1. But you will always, in scientific notation, have 1 digit to the right. So you can always do the 1 less than the exponent moving it left, but you cannot do it always, count the zeros. You understand what I'm saying? Because scientific notation says, once again repeating, that you write your number with 1 digit to the left of the decimal, and then whatever rest of the number to the right, and then 10 to the power of where you got to either divide by 10 or multiply by 10. Make sense? All right. So 96. I don't think I did that. So it's 9, 8. So scientific notation says 1 digit left times, and then we have to, how many decimal places do we move? That's how many times we put 10 to. And we're moving 9 decimal places, right? So we're moving 9 positions. We're moving it from here, and we're going 3, 6, 9. So we would go to the 9th. The next problem saying go to decimal notation. So it's 98. We go 6.2 times 10 to 10. 116. 10 to the minus 12. So what I can do, I'm going to have to move it 12 positions to the left. Because I know when I move left, I can go one less 0 than 12, right? Correct? So I just go, I'm going to go 11. 1, 2, 4, 5, 6, 8. Put my decimal place. And that's my number. Good with that? So 102 is 4.35, 10 times 10 to the 9. Now this is going to go right with your decimal, but because I have 2 digits, rather than putting 9 zeros, I'm going to put what? 8, isn't it? Rather than put 8 zeros, I'm going to put 7. 4, 5, 6, 7. So that would be where my decimal place would be. Okay? All right. Now, because when you're doing calculations with your calculator, and you're dealing in very large or very small numbers, it's real easy to not get decimal places right, not put enough zeros in. Scientific notation is helpful even running calculator. So if you have 104, and you got this 8.9 times 10 to the minus 5, and then you got 3.2 times 10 to the minus 6. You can drop the brackets, you can put the 8.9 times 3.2 together, and then you can put your powers of 10 next to each other. And then these two on the right, the powers of 10, 10 to the minus 11. So that's saying no matter what number you get, when you multiply these two together, you're going to move the decimal place 11 places left. Right? So then you can go and multiply your 8.9 and 3.2. You can put it in the calculator if you want or whatever. And so it's 8, 14, 8, 2. Now notice that this is 28.48, right? Times 10 to the minus 11. Now that's not scientific notation. If you change this to scientific notation, you'd have 2.848 times 10 to the 10th minus 10. But that is, we're not worried about scientific notation. We want to know what the decimal number is. Now, that says I would, if it were scientific notation, I would put 10 zeros. But because it isn't scientific notation, I got to put 9 zeros. Correct? Because I got those 2 digits rather than 1. So I'm going to go 2848. And rather than 10, I'm going to put 9. 1, 2, 4, 5, 6, 7, 9. There's my decimal, and normally you'll put a 0 to the other side of it. So that should be it. Should be 9 zeros, and then your number, in order to move it 11 places. Good with that? Now, 106. Am I going too fast? I'm zipping along here, so. 4, 8, 0, 0, 0, 0. And then we got 3, 6. That's 8 zeros, isn't it? And then a 9, 6. 9. I don't know. I put the guess. 96. So I'm going to write this in scientific notation first. Times 10 to the 5th, right? That's what 480,000 is. And then the other one is 9.6. And then that was 3, 6, 7, 8. So this is times 10 to the minus 9, right? Now then, 4.8 times 9.6, and then times 10 to the 5th, 10 to the minus 9. So my decimal is going to be moved 4 places left, right? After I get through multiplying 4.8 and 9.6. So 4.8, 9.6. That's right. So it's 46. So this is 46.08 times 10 to the minus 4. Now I'm going to, once again, rather than 3 zeros, it's going to have to be 2, right? Because I've already taken, and so then it's going to be 2 zeros, 4608. Now, I don't know about you, but when I put numbers in the calculator, when they're very large and very small, you can miss a 0 so quickly, so easily, and it throws your whole answer off. Scientific notation, if you count it out, will really help you to get correct answers. All right, any questions? Going a little faster than I did in other classes, so I want to make sure I'm not. So next thing we want to look at is 108. Here we got 2.7 times 10 to the 4th over 3 times 10 to the minus 6. So what we can do is we can take everything, we can go this 2.7 over 3 and then times and get this base number, and in the numerator that base number is going to be what? 10 to the 10? Is that right? That 6 is going to go up into the numerator as a plus. Correct? So now all we have to do is divide the 3 into the 27 and move the decimal place 10 places to the right. Correct? So the 3 into the 27 is this, isn't it? 0.9. 10 to the 10th. So now if I go right 10 places, I'm going to have how many zeros? I got one digit, 9 zeros, don't I? So I'm going to be 9, 2, 3. There's my decimal place. Correct? Now, if you put that in your calculator, you'd have to go 2, 7 with 3 zeros behind it, and then you'd have to go 5.5 zeros and a 6 divided by that. They're subject to a lot of error in that kind of problem, entering it in a calculator. You could even in a calculator, you could put this value in. You could put 2.7 divided by 3 times 10 to the 10th power, and it'll give you the answer. And that'd be a safer way of doing it than putting in those decimal numbers. So don't just throw scientific notation out because it looks, like because you got a calculator and you do it. It really helps you being able to do problems accurately. So 112. So they got 1, 2, 3. Is there 6 zeros? 3, 4, 3, 4, 8. 3, 4, 6. And then we got that's 6 zeros. And a 5. So that numerator we would write as 3.46, right? Times 10, and we got the 6 zeros and a 3, so that's going to be minus 7, right? And then the denominator is 5.0 times, and we got the 3 zeros, and so that's 10 to the minus 7 also. Now notice that these two, when you take that minus 7, the denominator up, means it's just 10 to the 0th power. 10 to the 0th is what? So that's just going to be 1. And you're going to have 3.46 over 5. So it's just going to be dividing that 3.46 by 5. And you just go 5 into 3.46. It's going to be 0.68. What is it? Did I do? I did something. 6992, right? 92. And what they want the answer is what? How? Decimal. So that's it. 0.692 should be the answer. You good with that? Did I go too fast? Any? Okay. All right. I got a quiz. I'm going to leave off there and give you the quiz.